So, colleagues, good evening, everybody. So today I'll make a talk on introduction to transformers, and I'll use a Kaggle competition CommonLit challenge as a kind of example. But the main idea of the talk is kind of introductory educational talk that is more related to just the general Hugging Face transformers, not to some particular details of the Kaggle competition. So let me start. Okay. So here is the first slide. So there are some general comments that so we organize these webinars quite regularly. And you can see our YouTube channel, Telegram channel, Twitter, so you can see the announcements of our webinars there. Also, if you wanted to make a talk, so please welcome, please contact me or other organizers, and we will happy to invite you to make a talk. So I think it's kind of very useful that not only the kind of experts can make a talk, but just people who learn something and want to share the knowledge. So today talk by myself, it will be just this kind of things. So I just learned something about the Hugging Face transformers, and I want to share it. And I think there are more experienced people here who know it better, and you are welcome to stop me and to discuss, and kind of, anyway, any discussions are very welcome. Oops. So the plan of the talk will be the following. So the first part of the talk will discuss, zero part, we will discuss the task which we need to solve. This is, we are given text and we need to predict the two numbers. So actually we have more than 7,000 texts, quite small. And we need to predict, we need to train our model on the 7,000 texts. And we will need to predict for the private dataset, which we do not see, about 24,000. So this is just about what we need to do. Now, so the main part of the talk is about how to solve this problem with the Hugging Face transformers. So the point is that we have kind of a ready solution for that. So you can use the model called, for example, DeBERTa, but there are also several other. And you just write something like train the model, and it will give you the answers. The problem is that it's not that much easy as, for example, with sklearn models, and you need to do some preparation steps. And I want to explain what are these preparation steps and maybe provide some details. Yes, sure.
Sorry, I just wanted to clarify a couple things.
Yeah, sure.
So you say given a text, predict two numbers. So text, what text? Is it a summary or actual text and a summary?
So yes, for the competition, we are given both the text, the summary. This is the main thing. The summary is the main thing. And we are also given the original text, which was for which the summary was written.
Okay.
Yeah.
So one original text and summaries for each student. Okay.
Yeah. Moreover, let me mention that in the trained data, we have only 4, not 4,000, but just 4 original texts and 7,000 summaries.
So basically 4 original texts and 7,000 people provided summaries for one of those texts.
Yes, and we know one for which this was the summary was for that we have the correspondence. This is given to us.
Okay. And I would put 2 numbers. What are those numbers supposed to be?
So the sense of these 2 numbers are assessment by teachers of these summaries by students.
And why 2 numbers?
One is called wording, another is called content. We will we have some slide where organizers explain a little bit you can look, and maybe you know better than me, since as far as I understand, this is American system. So this you see, so the first is content. So for example, yeah, how accurately did the summary capture details? Yes, and another wording. So, well, I'm not completely sure that I fully understand the meaning of this, and it fully corresponds to what I see in the real data, but at least there are some kind of comments, yeah, for that.
Okay. All right. And final question, when you said 7,000, 24,000, what's the difference between those two sets?
This is one is training set, 7,000 is training set, and private data set, so where we will be kind of our models will be estimated on this private data set, which we don't see. This is 24,000.
Got it. All right, thank you.
You're welcome. Yeah, but for the first part, all these details are not important. So for the first part, you can think that we have text as an input, and the output of the model should be the two numbers. And this correspondence between the text and the numbers is given to us at the train set. We can train our models on that data. Okay? Oops. Okay, so about the plan again. So the first part will be about the general educational part about the Hugging Face transformers. And the second part will be more about the details of the Kaggle competition. Okay, so in the first part, we'll discuss this DeBERTa, which is the most powerful ready solution. You just take this model and train it, and it will give you not so bad scores. And the other items in the plan, which we'll discuss also other transformers, BERT, but they are kind of unsupervised. So we can do something, but not exactly solve our task, but we'll need to do some additional steps. But it's also useful. Okay. So everybody is welcome to interrupt if you have any questions, so please ask. Okay, so again, about, so what is the task we need to solve? May I ask, Stas, for example, the task is clear or not?
Yeah, clear.
Okay. Yeah, so we have some text, and these are the students wrote some summaries. We have the assessment by teachers, and we need to predict this assessment by our natural language models. Okay, yeah. So that's the only thing we need to know for the moment. Okay, so now we'll go to the first notebook. So the first notebook will explain you how to solve this problem. So basically, the main command is trainer.train, and it will train the model and give you the solution. But before you do this train, you need to do several things. First is, so they are written here. So there, you guess some of them are quite standard. It's a conversion to the from the pandas data frame to the Hugging Face dataset. Then you need to do tokenization. Then you should prepare the arguments. Then you should prepare the model, and only then you start the training. Yes. So it's a little bit more complicated than for usual sklearn models. Yes, you need to do many preliminary steps. Yes. So just a moment. Oops, sorry. I have a link to notebook in the, just a moment. Yeah. Oops. Okay, so here is the notebook. Okay, do you see the notebook?
Yeah.
Okay, so let us look at this notebook. Okay, so the first step is to load the data. Yeah, and so this is the main part of the data. You see the text column, and this is the summary, and the content and the wording are the two assessments of this summary. So for each text, you have these two assessments. If they are high, bigger numbers, as far as they correspond to beta, as far as I understand. If they are lower, then yeah. The actual, so I think the organizer somehow transformed these numbers from the kind of the real assessment scale at the school to what we see is somehow some transformation which we do not clearly understand. So let us forget about this sense. We have just the numbers. Yes. So here shown the only 5 numbers, but in general we have 7,000 at the training set. Okay. Sorry.
Okay.
Okay. Sorry, I'm afraid our Zoom borders are coming again. So just that's why I'm. Okay, so this is the plot. So it's shown only for some part of the training set, the content and the wording. So this is the scatter plot. Okay, now we are going to the transformer model. So first we need to make some imports. This is the auto model, auto tokenizer. We'll discuss them later. So the first thing which we need to do is tokenizer. So tokenizer, the sense of the tokenizer is the following. So it takes the text and it transforms it to the kind of sequence of the special symbols. So basically, so typically something like each something like 3 or 4 symbols in the text or 5 letters in the text that transform to one kind of token, what is called token. Token is a number. So from each text, we will need to first make this sequence of the numbers. So here are the examples. So I take the text, for example, so text example, and we write Tira not tokenizer. So what we get is, let us print it, we get it something like a special class of the transformers called kind of tokenization. And here we see the sequence, yeah, input IDs. So this text, which was 2 words text symbol, was transformed only to 4 tokens. If you take this longer text, we will get more tokens. Yes. So the correspondence between the letters and the tokens, as I said, is not very simple. Something like 3 letters correspond to 1 number. Yeah, but it can depend. It depends. Yes. There are some exceptions when, for example, one symbol can be encoded by several tokens. Yeah, but all this tokenizer is doing for us. We only need to load it, and loading, actually, the tokenizer can be different for different models. So now we are using this model called DeBERTa. So here is somewhere the name of the model, DeBERTa-3, and so in the Hugging phase, first we load tokenizer precisely for that model. Yes. So I think there are general tokenizers which you can use for many models, but for some models you need to use the tokenizer for this model. Yeah. So is it clear? Something more or less. Yeah. So the first step is tokenization. Okay. Stas, is it clear? Yeah, okay. So the next step, this is some conversion. This is some kind of technical thing, yes. So we typically work with the pandas data frames in the Python, but now we need to, all these transformers in the Hugging Face, we work with a special type called the Hugging Face dataset. And now we need to make this conversion from the pandas dataset to this Hugging Face dataset. For this, we have just the command. So it calls from pandas, dataset from pandas. So it will create us this special kind of the dataset. So you can see the type of this object is something like dataset, arrow, dataset, blah, blah, blah. Yeah. So you can see the features, number of rows. So number of rows, that because in this version of the notebook, it's a very huge downsampling, not 7,000, but just only 100, just for kind of speed up. Yeah, don't be afraid of that. Okay. So now is what we need to do is the following. So now we need to tokenize, but not the examples which we have before here, some toy examples, text example, but we need to tokenize this dataset. So this is done in the following way. So the Hugging Face dataset have this command map. It's like a map, but for example, for pandas data frame, for pandas series, you have a map, but for pandas data frame, you don't have a map. It's a specific, I mean, map is the same as in pandas in standard Python. Map is something which takes one symbol and maps it to another. Yeah, and here, for example, the mapping is done with this function. So what this function is doing? So it takes kind of example labels. So what we want to do in this function? We want to, this function will take both text and the targets. So what we need to do is to keep targets the same, don't touch them, don't touch the targets, but tokenize the text part. That's what is this function is doing. Is it clear? Farid, is it clear?
Yes, Sasha, I think it is clear. Yeah.
Okay. So one of the important parameters in this function is max length. So what is max length? That it will cut the text to this max length. Typically, we have 512 max length. We can try to do it more, but I'm not sure this would be a wise step. But you can cut it. Okay, we can play with this number, but typically it's 512 to power 9. Yeah.
By the way, is this text editable for you?
I can, yes, edit it if you want.
If it's not difficult, you may want to align the code there because it's kind of hard to read. Oh, it was already like okay.
I'm sorry. Is it better? No. But is it better? No?
If you can go where you were earlier, might be better. I see. So you just printed as like some kind of more readable format, I suppose. Yeah.
Okay. Yeah, maybe.
Yeah, that's fine. That's fine.
Okay, just a moment. Okay.
Let's just continue. Don't worry about it.
Okay. Okay. So sorry. So okay. So what we have done is the following. So we take this text. We need to make a tokenization, and tokenization is done typically by this kind of command that you take the kind of this first create the Hugging Face dataset, then you write this map where you have the tokenize function and it works. And the main thing about tokenize function here for the train that it keeps the targets untouched. Yes, so the labels will be returned untouched and the text will be tokenized. That's what we're doing here. Okay, so the next step. For the training the model, we need to prepare the training arguments. Yes, so this is the set of the arguments which we kind of need to prepare for the optimizer of the model. So what is somehow probably most useful here? For example, here we have number of the epochs. So this is how many epochs will the new neural network will be trained. So typically what I see in this competition, people use 2 or 3, something like. In some cases, so most standard, I think 3, but I see that in some cases 2 is better. Yes, so that's one of the parameters. Another parameter is batch size. So we have actually 2 batch sizes. One is kind of training and another is for evaluation. And people typically take these values quite small. For example, this now I think 12, and you see that this batch size for evaluation is 8, very small batch sizes. Okay, so now the other parameters are learning rate, of course. So what is the learning rate? So typically learning rate here is quite small. We train the models with something like 501, this value, you know, I mean, more precisely 4 zeros than 1, yeah. So this is a little bit unusual for standard neural networks, but as far as in these language models, it's like this. And what we do next is, so there are some other parameters. For example, this is the weight decay. So I don't fully understand this value. As far as it's how the learning rate will be decayed with different batches. Now, so another parameters which we can use here, this is the save strategy and evaluation strategy. This is, for example, evaluation strategy that do we want to look at the evaluation set on the test set, each, for example, 100 batches. So you'll see here this parameter. So for this particular notebook, I disabled this. So I don't want to use evaluation set here. I put no. But if you put steps, and then you'll set these 2 parameters, for example, by 100, then every 100 steps of the batches, every 100 batches, it will look at the evaluation set and calculate the metrics. So you'll see how the metrics are kind of changing, not on the training set, but on the evaluation set. Okay, so and of course, this is the very important parameter. What is the metric optimized? So here it's RMS here. Okay, is it clear? Stas, is it clear?
Yes.
But it's clear.
Yes. Yeah, completely clear. You're good.
Okay. Okay, so there is another content, another config. So this is config called autoconfig. And you see the following code. So first, we can load this configuration again for the model. So here is this DeBERTa, we load it for the model, and then we can update it. Yes. For example, there are 2 parameters which people update here. This is some dropout probability and attention probability. They send something, well, maybe here 0 and here small value to 0.02. Maybe it's not that much important. And what is here important is, yes, please ask question. You can unmute yourself.
Yeah, hi Alex. So
Hi.
as you know, in this competition there are 2 targets, but in your example I see number labels only 1. Yeah, this example for 1 target or just example or you have two models for every targets?
Thank you. That's a very good question. So I want to put this as an exercise, homework. Modify this notebook such that it will process two targets. So this version of the notebook is training only one target. So what we will need to change first is this line, yes. So you will need to change, need to change here by 2, but there will be some other changes which you will need to do. That will be a homework. No, I will explain it. Actually, I will give suggestions on this homework a little bit later. But yeah, this is correct question. So this is, as I said, in this competition, we need to predict the two targets simultaneously. Yes, two numbers. And that is precisely what is we need to change this config. So you see, if you want to standard is just one target. So in this notebook, I simplify things. I just take the first column and predict only the first column. And for the submission, I will put zeros for the other column. Yes. So this is notebook is just for educational purposes. That's why here is one. Yeah. Again, so let me comment. So we have many parameters, but what is the difference between these parameters, training args, and these parameters? So who knows? Stas, can you guess? Farid, can you guess the answer? What is the difference between these parameters and the other parameters? Why we split? Why there is no one config which serves for both? Somebody knows? Okay, I don't.
We would try to avoid overfitting or something like that. Yes, or
well, in some sense, it's more technical. So these parameters with autoconfig, they change the model itself. But these parameters, they train their parameters for the optimizer. You see? So for example, for the model, you have something like a dropout. Yes, and if you change, for example, you said something like, I want the model to have dropout 0.3. And so you put it here. This is parameter of the model, but not of the optimizer.
oh, you mean Gipper hyper parameters?
Yeah. Hyperparameters, yes, exactly. So these are the hyperparameters of the optimizer. Yes. So how many epochs? How many? What is the learning rate? What is how learning rate decays, and so on and so forth. Yes. So these parameters are training arguments. They are used mainly for the optimizer, and these parameters are used for changing the model itself. Yeah, is it clear?
But in my understanding, the dropout rate may actually have impact on how you optimize the model too.
Yes,
that's how I would think intuitively.
Yes, but no, I mean, for example, even if you take, for example, simple rich regression, you have the parameter of the model, alpha, which is how strong is regularization. But you also, and that's basically the only parameter of the model itself. But you can find the solution by different way. I don't know, by the stochastic gradient descent, whatever. Yes, this is not the model parameters, but the how you make optimization. Yes.
Okay.
So that's why these two things are splitted. Okay. Now, okay. Yeah. So this was the parameters, and now the model itself. So the main thing we need to kind of set the model. What will work? Yes. So for example, in sklearn it can be, I don't know, random forest. It can be logistic regression. And here the main thing is that we need to set this model. This is a complicated neural network. Moreover, it is already pre-trained on the large. So the setting the model is this command. Auto model for sequence classification from pre-trained. Here we put DeBERTa, but there can be other examples. So this is the main model. So if we see this variable, you will see brief description of what's going on. Yes. So you will see that it's a kind of typical description for the neural networks. You will see some, for example, dense linear, yes, GLO activation. You will see something like layer norm, yeah. So, and some more complicated layers like DeBERTa encoder, so on. So this is some kind of description of that model. So you see it is okay. Even in the condensed form, it's not fill at least my screen. Yeah, so it's quite big. Stable dropout and so on. So this is the description of the model. Almost last thing which we need to do, this is quite technical. So this is a data collator. So it's something like about how we organize the training process into the batches. So let me don't go into the details. Now the final thing. So now we are kind of ready to everything. And so here is the main instruction. It will give us a model. It will train our model. It will train our model on our data. That means that we take, so this is the trainer class, which we need first initialize. So, and here we need all these parameters which we discussed before, this training argument, this model content, this is the model itself, this is this neural network. So we need this is the training data. It contains both, it contains as well as features, the text, and targets also, yes? So here, text is already tokenized, and targets they're untouched. Also, we pass as a parameter the tokenizer and the data collator. And then we write this command train.train okay, so success. And so you can see how it is training. Is it clear?
Yeah, sure.
Okay, so important thing to understand here that all these things, they like GPU. So here you see the 5 minutes, it was on the CPU because I put only 100 of samples, only 100. If we need to train on the real set of 7,000, it will be something like 3-4 hours on the CPU. And on GPU, it will be something like maybe 5 minutes. So the difference in speed, in time for GPU and CPU is about 50 times, 50, 60, 70, something like that. It depends. But without GPU, it's quite difficult. You can only kind of make exercises with a huge downsampling. And now, okay, so the other part, this is the, now we should make predictions. Now we should make predictions. So, or in the other word, what is called inference. So basically, we need to do the similar steps. So we need to first prepare the data set. So we need to make a, so this command is a data set from pandas. And so here we have only text. There is no targets because this is for submission. We don't know the targets. And so here we have tokenization, the next step. Again, there is no target, so we don't need to write this thing with the labels, which you have seen before. And so this is a tokenize function, which is a little bit different from the train, yes? So the difference is that in the train tokenize function, we have this part which takes care of the labels, which says that the labels should be passed untouched. Where is it? Yeah, it's here. You see, this is the labels for taken like this, target column. Yeah. So this is for train. And for test, for submission, we have this a little bit different. The difference is very small that we do not need this this part which take care of the labels. Okay, and then the same. Test dataset, map tokenize function for test. Okay, this thing is ready. Now the second step, model content.eval. So I guess, Stas, you should know what is it, yes? Can you explain to the others?
Sorry, can you repeat?
What this command, what this instruction is doing?
Is eval metrics by each batch size or epoch? Okay,
maybe ask the question in the wrong way. So the answer is this is a special command for any neural network in the PyTorch. That means it sets the model in the special mode where, for example, you don't need to calculate the gradients, and there is some changes how the dropout layers are working. So this you say now after that command, the model will be in evaluation mode. So I need to make predictions. I will not train. Yes.
It's inference. Okay.
Yeah. So this is the general command for the PyTorch, that after that command you will not train. You will make only the inference.
Okay. Got it.
Yeah, again, so here you have prepare the arguments which you do train false, yes, do predict true. That's quite clear. The batch sizes for small batch sizes we already discussed. So that's, I guess, is clear. And so now you use again the same command trainer, the same as for the training, but now you need it for inference. You write again, the main parameter is your model. This is this huge neural network, tokenizer, which we discussed before. Again, this data collator, which is kind of for batches, and these test arguments, which we discussed here. Yes, so this is no only technical things, nothing special. And then this command which you write, that's info content.predict and prediction. Wow, that is the result. So we have the predictions. Yes, and so okay, sorry. So for this, so this will be prediction. So for in this example, I predicted only one target. I think it was content. And so what I have done, I just set them both 0 and then saved predictions here. Yeah. Of course, the public score, when you submit it, it will work, but the score will be not so good. It will be just, okay, it's not written here, but it's 0.7, because we predict only the one target. So, okay, is it clear?
Yeah, it's clear.
Okay, great. Okay, so to conclude, so some what we learned from this, what are the take-home messages and what are the homeworks. So first, GPU is very necessary for this task because it will be 40-70 times faster. And with CPU, if you want to train it will be 7 hours, something like that. Terrible. So, okay, now if you think that you understand this code, you can do the following exercises. For example, take it, try to change some parameters and make a submission. Yeah, that's the first exercise. So I don't know what parameter. So I would suggest, so the standard parameters to change is something like learning rate, for example, number of epochs and so on. Yeah, so it's quite natural to change them and to look on the results. Okay, so the second exercise is more difficult, is to change the code to make it to work on 2 targets or maybe more. So one of the things which we need to change, we discussed in the previous, already discussed, this is in the training arguments that we need to change this number of targets. Yeah. Another exercise which you can do is something like to change the code such that it will show us the evaluation metrics. So typically, when we train neural networks, you will see something like that. It will be something like going from left to the right. And here it will show you what is the training loss and what is the evaluation loss. If you set the parameters, which will say that I want to see the training loss or evaluation loss each number of steps. And here are the steps. For example, eval steps. Yeah. Okay, so these are the homework exercises. Yeah. Is it clear?
Yes, Sasha.
Yeah.
Okay, so maybe, so I have the second notebook, actually, where part of the exercises is already done, but I think we are kind of maybe not so much time left, so maybe I will skip it. Yeah. But so let me show you some other notebooks.
Okay, can you just say in one sentence what the second notebook all about? Just one sentence.
It's more or less the same, but technically more kind of complicated. This I want to introduce the cross validation. I want to introduce this validate, so the make kind of real thing. So you split to the train and test to faults,
Okay.
train of each fault, and in that notebook I will have two targets. So
Okay.
if you don't want to make exercise by yourself, you can look at this notebook, and the second notebook works with two targets. And
So you allow us to cheat. Thank you.
yeah. Okay. So maybe now I will go to just summary. So the task which we need to solve was we have text and several numbers. And the solution is that Hugging Face already have models which can solve this task for you. Yes, just precisely for this task. Yeah. But probably you know that typical, for example, this BERT or other transformers, they are unsupervised. They cannot solve this task for you. I guess many of you heard of this. So what BERT or other these packages do, they do kind of embeddings. Yes. And on top of the embeddings, you can build your own model and try to predict the targets. Maybe it would be useful to consider such notebook also. Oops, sorry. Just a moment, I'll find the place where the sentence embeddings. Okay, again, so what we want to do in this notebook is to compute the sentence embeddings. So we will use different model. It's not DeBERTa, but some mini LM. I don't know exactly. Just I looked at the public notebooks. This was chosen, and so I took it also. So I don't know much about this model, but you can see here again what is all about. Yeah, this is some BERT type model. You have these layers of the embeddings, layer normalization, dropout, so on and so forth. So when you just auto model, load it, then you can just print model and it will show you this description of the model. Yeah. And so the difference with the previous notebook that here it was in the previous notebook, this command was auto model for classification. And here there is no classification. Here in this notebook, what we discussed, this is completely unsupervised, just to compute the embeddings. And so the model is called auto model. not the auto model for the classification. Again, first what we need to do is tokenizer. Again, this tokenizer is coming in the same package as the model, so you need to load from this model first the tokenizer, then you load the model. Yeah, and now so here we want to get the text embedding. So here is some code with the function which is quite simple to get the text embedding. So it takes text as an input. So first we make a tokenization. Yeah. And the second thing, again, we do embeddings. Embeddings, again, we first switch the model into the inference mode and the evaluation mode, and then just apply model to our input. Yes. Input is tokenized text. So we take here text, tokenize it, and put this tokenized text into the model. And this is the embeddings for no, more precisely, we get this one, and then we need to take the last hidden layer and make aggregation. And so this is the matrix, and to get the vector embedding, we need to calculate the average like this. And so this will be the embeddings. Okay, so now let us look how it goes. So we have this, for example, code which just goes through the trained dataset, takes this text, calculates embeddings. And so we get the matrix of embeddings. It can be quite maybe interesting to make a visualization of this embedding. So what you will see here, guess what you see? So as I said, in train, we have only 4 prompts, which correspond to different, this means the 4 original texts. So there are 7,000 summaries, but the original text only 4. And when we make embeddings, we quite clearly see the kind of clusters. Yeah, no, so I colored them, but we can also see them. What is a little bit, so this is this picture. What is quite interesting that if I color this by the targets, I see that they are kind of, the targets have higher values at the end of the clusters, somewhere here for each cluster. So if you a little bit think, then you can make a kind of feature from this. But what I have checked, that feature is not that much strong. Yeah. So what is nice that we clearly see the clusters which correspond to different prompts, but as a feature engineering, maybe it's not that much good. So I considered here UMAP and PCA and ICA several embeddings. More or less all of them shows these clusters.
So why did you say feature was not strong? What was the point there?
I constructed the model based on this feature, and I looked at the score. And so I see that the score is not that much high as I expected.
And the feature was, what was the feature doing exactly? How did you define the feature one more time?
No, just let me explain first the idea. So you see these clusters, and where I color the cluster by the target, I see that at the kind of one end of the cluster, the target have higher values.
Okay.
Just a moment. Oops, I don't. Sorry, Farid, это у меня звонит или у тебя?
Но у меня не звонит
У
ничего.
меня это звонит. О, sorry. I'm sorry. Okay. Okay, so okay, so the idea of the feature is the following. So if you see the cluster, the feature have higher values at the end of the cluster, yes? But so you can, roughly speaking, take, for example, ICA1 as a feature. But the problem is that these clusters are kind of rotated. So for one, it is kind of you should take ICA with the positive, with others negative, with others for ICA 2. So what I tried, I just used something like first I make a quantile normalization of this PCA, and I checked that for all the clusters, the pattern is preserved. That I see that the higher values are now for PCA1, for higher values of the PCA1. So the quantile normalization of PCA1 seems to be not so bad feature. Yeah, I checked, but it's not really very strong. So maybe all these things. So one of the really strong feature is just very simple. It's length of the summary. How many symbols for this particular task? I don't know why, but maybe it's natural that if student is writing very long summary, the teacher will kind of see, okay, so this student is maybe kind of put lots of efforts in this summary, so I will kind of put him a good mark. I don't know. Okay. Maybe this is the reason, and maybe this feature with PCA is very strongly related. So my model here was actually on this length and on PCA1 both, and it doesn't give a big improvement to the only length. Yeah. Okay. So this is the score, I think, best score, 6. We'll discuss the score at the end. Okay. So takeaway message that you can take, the take-home message is you can take text, you can apply these models, and if you apply, for example, the PCA or UMAP or whatever, you will see the nice pictures which will show the something like the clusters. Maybe you can construct the features from them, but these features may not be. It depends. Sometimes they are not so bad. Sometimes they are not so good. Yeah. Is it clear?
Yep.
Okay.
Yeah, I understand.
Okay. So it can be the exercise is to try to kind of repeat something like that. Okay, so the next notebook which I want to mention also very quickly is by our previous reporter, Ivan Glebov. So the notebook is called No Transformers, but not so bad. It's really like this. So Ivan already discussed it, but maybe I'll repeat some ideas of this notebook. So what's going on? So here in this notebook, he also do not use this fine-tuning. Don't use this fine-tuning. But what he is doing, he still is using this DeBERTa-like models, or more precisely the embeddings. And what he is doing is the following. So he said he constructs the distance between the text and the prompt text. That means between the summary is text, and this is prompt text, this is original text. And he calculates this distance. First, he calculates the embeddings, and then he calculates the distance between them. Is the idea clear? And so what he says that these features are quite good. So when he constructs his model, he will have something result like sorry, this is okay, this is okay. So his result is like this. It's almost I don't know. In my previous book it was 0.6, but he have 0.5. So in this notebook, he constructs several features. Some of them are based on these embeddings, and they are based in the following way. He constructs the distance between the embeddings of the text and the embeddings of the from original text. So here is a nice table which shows the correlation between the features. And so, for example, you can see that this feature which he constructed is correlation between one of the targets content and this feature is quite big, 0.58. Yeah, and with other targets maybe smaller, but still it's quite big, quite significant. Yeah. So that is another example which I wanted to discuss. And the final example which I want to discuss, but not go into details, is the following. So this is one of the notebook presents the following idea. So we have BERT model, which again, BERT model by itself is not for supervised training. But what people do here, they do the following. So they construct the PyTorch neural network where the first layer is BERT, yes? But then you construct the standard layers for the standard neural network, yes? So you take here puller, dropout, linear layer, ReLU, linear, and output, yes? So one of the, so this is quite an interesting idea. I think that you can, another alternative way to use this BERT model for the supervised task. So he constructs this model on top, so he constructs the neural network on top of the BERT model in this way. Unfortunately, the score of this model is not that much big, but the idea is quite interesting. Yeah. So to summarize, we have several ways how to use this Hugging Face embeddings for this solution of this task. The first way is most the best way is just to use specially designed model which can be just used for this task. Just you put here text and your targets, it's trained itself, and it gives you not so bad results. Yes, that what we discussed first. And there are some alternatives ways. One of the make embeddings, and you can make features from embeddings, and you can use any model based on these embeddings. Yeah. Another is to construct these features distances, and another way is to use this neural network on top of the BERT model. And so this is probably the end of the first part. So if you have any questions, it's a right moment to ask. Any questions, comments, suggestions?
I think a pretty good explanation for you.
Okay, thank you very much. Okay, so now we can move to the second part of this talk, which is just about the more about the competition. So now we kind of learned, so the educational part we can consider as finished, and so maybe we can discuss, if you want, if you are not tired of the competition itself. Yeah, if you are tired, please tell me, and we can kind of rearrange, for example, meeting. I thought I'll present all this material in 15 minutes, but it seems that I make a mistake for times. Okay, so what is the competition? So you see here the leaderboard. So one of the famous guys called Psy, Philip Zinger, is on the third position, but maybe sooner he will become leader. Okay, so we have already have the talks on this by Ivan Glebov. Please look for this, for his talk. Also, now let me discuss brief ideas and brief kind of situation on the competition. It is the following. So, let me, here is the leaderboard score. So as I say, there is one very simple but very powerful feature in this competition, which is just the length of the summary. How many symbols? So if you use just the linear regression on this one feature, you will get the score 0.64. So we can consider this as a kind of simple baseline and compare it with the other models. Now there is nice notebook which gets a quite better score, 55, which use very simple things. I'll discuss it later, but just some counts, number of exclamation marks, I don't know, count of words and so on. Very simple feature. No deep learning, nothing else, and you'll get score 55. So the next achievement is by Van Glebov. So you need to now use, which we discussed before, this we need to use this BERT embeddings and some other features which are common in the natural language processing, and you'll get 53. All this is without this fine-tuning. Now, if you use this fine-tuning approach, which we discussed first, you'll get a better score. It will be 49, about 49. Yes, and but it's still not on the top of the public notebooks. So what the public notebooks do, they combine the two approaches. They combine the fine-tuning of the DeBERTa plus these features from these previous notebooks and make a kind of light GBM stacking on both models. And so the top public notebook is 65. This is also the end of the bronze zone. So if you will create notebook which is a little bit better than public, then you will get a bronze model. Actually, the silver medal is not so far. It says in the 66. This number. Oops, sorry. Yes, and the top zone, gold zone, is 440, around 42. So here you see, I think the main approaches which are used in this competition, at least in the public notebooks. So the main thing is this fine-tuning of the DeBERTa, which we discussed first, and the other things you need to combine it with some different feature which you make kind of handmade features, let us say like this. There is one exception. So one person presented a notebook which no birds, and he writes a neural net from scratch, just on the text. And he achieved quite a good score, even better than this fine-tuning of the DeBERTa. So this is quite complicated notebook, but kind of very impressive. Yeah, so it's also there are some other ideas in the notebook. So they use, for example, other models, mobile BERT, the model above BERT we discussed, and for example, one of the notebooks discussed the French to English translation and back for the augmentation of the data. Also quite interesting idea. Now let me discuss the so what is about cross-validation. So cross-validation in this competition is quite a simple scheme. We have these 4 folds which are related to this 4 prompts, 4 original texts. So you made a fold which corresponds precisely to these prompts, and everybody using this scheme, so we can compare the cross-validation scores between one another. Now, about the correspondence between the cross-validation score and leaderboard score. Well, there is correspondence, but it's not perfect. Yes. So, for example, there are some. I looked in the Ivan's notebooks, and you see that it can be that CV have such a not so bad boost, but leaderboard goes down on approximately the same number. That you should kind of take into account that here the correspondence between LB and CV is not perfect. Maybe we should more trust our CV in this competition, because there are some posts on the forum that in the public leaderboard there is only 1 prompt. In train we have 4 prompts, which is quite better. But still, it's a kind of typical problem. We don't know what to trust CV or LB. It's better that we both should grow.
So sorry, can you repeat what you just said about 4 prompts?
No, I mean, if we have problem between the correspondence between our cross-validation score and leaderboard score, it is always a kind of painful problem. There is no standard solution for it. Yes, the best way, which we hope that both scores are growing, so we kind of update our models in such a way that both cross-validation increases score and leaderboard score increases. But sometimes you get stuck and
Oh, okay. So I guess what you were saying is when you do training and you check your sort of score, it looks maybe improving, but then when you do on the private set, it kind of drops, right? It doesn't show up.
Yes, this can happen, and I even give the example with the numbers. So, for example, in this example, cross-validation grows like this, and the leaderboard goes down more or less by the same number. Yeah.
Okay.
Yeah, and this is a painful, kind of. We don't know. There is no standard solution for this. So it's always we need to think what's to do.
Now, I was going to ask you earlier, like when you talked about all those options, or would you be able to put links to each corresponding notebook, maybe in the bottom of each slide?
Yes,
not in the slide, but in the comment
yes,
section. Like,
there are links, but they are not here. If you see,
yeah, that's what I mean. Okay.
Yeah.
There are. Yeah, thank you.
So let me discuss several notebooks from this competition. So this is one, as I said, the most simple notebook, which obtains not so bad score. And you can look what is he doing. He just constructs several features, about 20 features, and makes them boosting based on them. There is no deep learning, no BERT, no nothing else. What are these features? They are very simple. So, something like word count, sentence length, vocabulary, average word length, comma count, semi-comma count, you see, exclamation count, and so on and so forth. Yeah. One of the main features is, of course, just the length of the whole summary. Yeah. And all on these features, you can get this kind of score. Actually, there are many deep learning models which obtain worse score than this simple. Okay, I think that's pretty nice notebook. Now let us look on the structure of the top public model. So what is done here? Here, as we see, they use DeBERTa, the model which we discussed. So we discussed this as a fine-tuning of this DeBERTa precisely to these targets. But also they use some feature engineering. That are some kind of features like this or another features. Yeah. So first you train DeBERTa on text. You take these features and you put everything to light GBM. And it predicts your volume score, and the same for content score. You take DeBERTa predictions and you take features, and so this is a kind of stacking. Yeah, is the idea clear?
Yeah, main point is clear.
Yeah, and so at the end of this notebook, they even provide how their kind of changes, historic changes, what was going on. So they started from the just DeBERTa model, they obtained the leaderboard score like this. Then what they understood that if you take not only text, but you take the prompt question and prompt title, add them to the text and put all this into the DeBERTa, you will obtain a better score. Here the improvement is quite small, but I guess actually it's bigger, because in my cases it's bigger. Okay, so now the main improvement.
Sorry, so, Sasha,
Yes.
Quick question. So fixed summary text, I understand. What are prompt title and prompt questions? Can you give examples?
Yes, sorry, I have not explained it before. Actually, maybe I haven't explained before both prompt title, prompt question. That means, so prompt question is the following. It's something like, please, summarize the text and go, for example, please cite some details which kind of confirm your point of view. So this is in prompt question, there can be direct kind of order. Please make a quote from the original text such that will confirm your statements and something like that. So this is for some prompt question, but for the other, it's not like this. It's something like don't kind of explain the ideas, but you don't need to go into the very details of the sorry, okay. I'll need to open the notebook and show you the details if you want. But the idea is that prompt question is kind of what you need to do, not only summarize, but some details which emphasize you need to do not only summary, but you do this and this and this.
Okay.
Okay. And prompt title is not something very kind of just the title of the original text. It can be, I don't know, from Aristotle or something like from the third wave, so the name of the book.
Mm-hmm.
But I think this part is important because sometimes it says you need to find the kind of direct quotes in the text, in the original. You need to put in your text the direct quotes from the original text. And that probably is one of the criteria which we can use.
Okay.
Anyway, so the main thing, the main improvement comes from this LGBM. So from here to here, you see my mouse, I'm sorry.
Yes.
Yes.
So the main improvement is here. So first they constructed the fine-tuning of the DeBERTa, which we discussed. But then you need to construct some features. Features we also discussed, but then you need to combine. And you'll get something like top score. And no, well, it's not that much easier. There are some modifications. So you see, they write something like, maybe it's in the other place, something like first attempt, second attempt, third attempt. So they obtained the score not kind of from the first attempt, but from the, they made some small modifications, and they finally get the score. Okay, so and another interesting thing that in this notebook they use fixed mix spanning. So what they do, they take text, then they run the spell checker and correct all the mistakes, and they put this corrected text into the DeBERTa. And they say that it sometimes helps. I'm not sure. So there are some discussions on the forum that maybe it not helps that much. And the main problem that this spell checker, some of them have the licenses. And in this competition, they are very strict that you can use only something like MIT license, but not the other license. And so there are lots of discussions on the forum about this license for the spell checkers, what you can use, what you cannot use, and so on. Just this slide that I wanted just by myself, I thought it's very simple to do this second, but when I tried to do it, I observed that this is not that much simple. It is quite strange. I just tried to do it yesterday, and I was a little bit shocked, but that it should be very simple. You get the predictions by the DeBERTa, combine these features, put it into the boosting, and you get it. But when you do like this, you get that score is worse than just DeBERTa. I am very puzzled. I don't know what. So I need to look in the original notebooks and to kind of understand what are they doing. Well, there is some details. I think I'm missing some small details. Another thing about the another thing about this, that the targets which we see, they're somehow strange. So probably the organizers take the original targets and somehow change them. And what one of the persons observes that he says that if I take the targets, this wording and content, and then rotate the picture 30 degrees, I will see that a kind of points are aligned into the lines. And we see some discreteness. So we see that here are the points that somehow clustered. So probably this means that original targets, original assessment marks for the students, they were integers. But the organizers made some tricks, maybe added some noise, something like that. And when we look without this rotation, we don't see this structure. Is it clear? It's quite
Yeah.
technical, but it's quite funny. So this sometimes happens that organizers don't want to give us the true targets, but they kind of add noise or made some tricks. And people who find what was the idea of these tricks of the organizers, they can use it to improve their score. And so there are many discussions how to try to use it, but it seems that it doesn't give a so people have found that there is something, but have not yet found how to use it to improve the score. At least I don't see it in the public notebooks.
So just on that previous slide, making sure I understand. So you have 4 colors for different prom IDs, and that means 4 different texts, right?
Yes.
Okay. And you're saying you're rotating by 30 degrees. Which set?
All this this scatter plot for all the targets. So here all the 7,000 targets are plotted, and when we rotate it, so this is a rotated picture, and you can see that these dots, they kind of align.
Oh, okay.
lines.
So you're saying it still would be lines, but they would not be vertical.
Yeah.
Okay,
Exactly.
okay.
Yeah. It still will be line, but it will not be vertical. Yeah.
Right.
So we expect that lines should be vertical and horizontal because we expect that the original maps was integers. Yes. So something like from 0 to 100. But very often organizers doesn't want to show us this information and make some tricks to change it. Another thing about details about this competition, that, for example, if you looked on some targets, on the values of the targets like this, for example, if you see my mouse, you see that this pair of targets is repeated 426 times. Yes, this pair of targets is repeated 380. This like this, yeah. What is the reason? So this is again something kind of strange. So I don't think this is. So this is not. I don't know.
So some scores are negative, right? Is that what you're saying?
Well, they are negative because I think they made the standard scaling.
Okay, normalization basically. They normalized.
Yeah. So I think the original targets were not negative, but organizers made the standard scaling. I think so. And but the strange thing that we have some pairs of targets which repeat many times. And if we look what happens with the models, how they predict these particular points, we see that models cannot predict it well. You see, so this is the prediction, this is the true value. And we see that many points, they have the same true value, but prediction is different. That means for this, many of these repeated targets, our models do not work perfectly. So if we understand what is the reason, then maybe we can kind of improve our model, but it's not so clear. Is it clear about this? Well, this is just a technical remark about the competition.
Yeah, I think I understand.
Okay. Okay, this we have already discussed. So this is the sense of this content and wording. So as far as I understand, content, something like about content, and wording is how good is your language, maybe. But I'm not completely sure that Also, with this rotation, I think that the kind of the sense of this assessment was distorted. And the final slide, I think that ideas to try. So I made a small experiment. I take the summary, both the summary and the original text to the ChatGPT and ask ChatGPT, so what ChatGPT you think, is it a good summary or is it a bad summary? And it give me, for this particular summary, quite a good mark, which corresponds to the targets in this competition. So I think that ChatGPT can help us to kind of do these things. So if anybody can think in this direction, that can be interesting idea. Okay, so thank you very much. That is the end of the the end of my presentation. I'm
So
sorry
what's the end
for
of the competition?
all the inconveniences.
When is the end of the competition? When does it end?
It should only 1 month more, I think.
Okay.
Yeah, thank you about this explanation. It's very clear and interesting.
Okay. Thank you very much.
Maybe we should try to ask ChatGPT examine this text like Americans teachers.
Yeah.
And use same points, I guess.
Yeah, that can be that can be one of the possible approaches. Yes, the only thing that so there are these license problems. So as far as the rules of the competition, that you should use only those packages which have the free license for commercial use, and I think you cannot use precisely ChatGPT. But there are some other big language models, and even the organizers by themselves provided the example of the notebook with another language model, which is LLama, which you can use instead of ChatGPT. So I want to try this. It's quite interesting. So just let me find it. I have not yet tried it, but I think it will be interesting to try. And so, as for instance, this is free model which we can use. Yeah, let Llama summarize CommonLit entries for you. So here he proposed to make summaries, but my idea is that we can go further. We can even try to ask these big language models to make an assessment, and we can look how good it works.
Well, yeah, interesting.
Yeah. So, but there is an interesting notebook by the organizers, so they suggest by themselves you can use it. So that would be interesting to try. Any other questions, suggestions, comments?
So how much time you spend on this competition so far, approximately?
Well, maybe 1 week, something like that, or maybe 1.5.
So this would be what? 1 week means 7 days, 2 hours each day?
Maybe more.
So 20 hours?
Yeah, maybe.
No, it's quite impressive, actually. You've done so much work. Yeah.
Yeah.
I'll definitely take a look at your notebooks, and I'll ping you later.
Yeah, you're very welcome.
Yeah, thank you.
Yes, so we also participated in the previous competition on the proteins. So there was also many use of the language models, protein language models. And what is interesting that kind of it seems the approach is quite different. So here we see that the best approach is to take this language model and fine tune it. Yeah, this is the standard approach for all the natural language processing models. Just take big model and fine tune. But for the protein challenge, which it had before this CAFA, this approach doesn't work. So people try to fine tune the protein language models, but it doesn't provide a good result. So what everybody finally did, they use only the embeddings. Just take the protein sequence as a kind of sentence and calculate embeddings, and on top of this embeddings you can build XGBoost or PyBoost or neural network and combine all of them. Yeah, so that's one of the strange things which kind of
But
I need to understand.
why is it strange? Because if I understand correctly, fine tuning is something you do at the very end, right? You still need to do a lot of work to train the model.
Yes, but
You use language model for proteins, you kind of bypassing this step.
just a moment, just a moment. Sorry, Farid, please, can you repeat the
No, I'm trying to understand why you're surprised. Maybe I'm missing something. So in my understanding, language models, they go through a lot of training first.
But the same, this is the protein language models. They have trained, as for instance, on the millions of the protein sequences.
Oh, it was a specific model for proteins. I see.
Yes. So people from even Facebook, they have a team which worked on these protein things. It was first, it was success by DeepMind with AlphaFold. I think you've heard this AlphaFold.
Yes.
And then people begin to kind of lots of activity in this field, and one of the activity was to use this to construct the embeddings via the specifically protein language models. And what we
then it's probably just different domain, right? The different set of proteins which were not represented in the original models built by Facebook or whoever.
Well, I'm not that much expert, so my expectation was that these guys from Facebook, they trained on all the proteins which were available. That means maybe hundreds of the millions, but maybe I'm mistaken, maybe I'm wrong. Yeah, so I'm not quite sure. So my expectation was that it was trained on everything possible, and that's why I expected that it will work fine-tuning. So not only me, people expected that fine-tuning will work very well, but no, embeddings by themselves worked quite well, but fine-tuning doesn't work. And here in natural language processing task, it's of course different. You take the fine-tuning as we discussed, it gives you good result.
Okay.
That is a kind of strange. Not quite understand why. So I want to apply these protein language models to some tasks, but now I'm a little bit puzzled. What should I do? Should I kind of continue with attempts to fine tune, or just use the embeddings? You know. Okay.
Sorry, can you explain the task of competition in few words and few words about way of make notebook in few sentences?
You mean what competition? This current CommonLit or CAFA?
यार जो नया वक्त तक खुल गई वही वाला जो सबसे पहले वो नहीं बोल रहा था खुद ही चल पड़ती स्टार्ट होने के बाद
guys, I'm sorry. I don't-
Yes, this competition.
this competition.
Um, um, you concatenate first part is not full text of student, but only name of text, yes, then question, and then student answer, yes.
Just a moment. Just a moment. I'll try to explain in more details. Okay. This is just a moment. So in this competition, we have first summary, then we have the original text, which is quite long. And it's difficult to use the original text because of this problem with tokenizer. Tokenizer takes only 512 tokens. But the length of the original text is much larger. You cannot put it into the token. Well, you can, but it will have a problem. Yes, that's one of the points which we need to keep in mind, that it's not quite easy how to use the original text because its length very long. But we have not only original text, but we have the title of the original text. Just a moment, I'll show you. Wow. Okay. Oh, yeah, here you see. So we have for this original text. Yes, we have the title. The title, for example, this one, on strategy. That means that this text is from Aristotle, yeah, and the name of this text is on strategy. I don't think this is very informative, but here we have this prompt question, which says that a kind of detailed task not only summarize, but it says you, for example, summarize at least 3 elements of the ideal strategy. Yes, so you need to point some quotes in the text, which at least 3 quotes. Yes, so this is quite informative. This is another, yes, for the other original text. This is the task. Again, it's more detailed than just summarized. It says incomplete sentences summarize the structure of the ancient cite the evidence from the text. Yes, so here we see that this task directly says that you need to make a citation from the original text. Yeah, is it clear? And so what people do, they concatenate the summary and plus this and this, and they send into the DeBERTa this concatenation, this and this. I made some funny experiment, and I played with the order. So you can change the order: title, question, and the text, and you can reverse the order. In my experiment, I see that the scores are different. One of the kind of orders is better than the other. It's quite funny, but it might work. Yeah. And another point, for example, you can do the following. You can so as we discussed, the length of the summary is an important feature by itself. So what we can do, we can try to put this feature into DeBERTa. But how can you put this feature into the DeBERTa? So it can be the trick, the following. So you just make this function which takes the length and it coded into the words. If the length is small, you write quite a short, middle, long, and then you concatenate this text with the text summary and the title and the prompt question. It seems to me, again, I see a very small improvement in this course, but I'm not completely sure that this experiment was correct. But I think in general, this can be kind of one of the ideas to try, that we know some features which are quite good, and we can write some text based on this feature, add it to text, and send it to DeBERTa. Maybe DeBERTa will kind of understand what's going on, that this text is helpful. I don't know, is it clear?
Yeah, like additional categorical feature by plus, I mean, like categorical feature translated into the text.
Yeah, exactly. Yeah, but DeBERTa can take as input only text, nothing else, just one string of the text. So if you have not categorical, you first need to make a text from it, and then kind of concatenate, and then send to DeBERTa. So we can do lots of things like this. So we know that there are many features which we discussed in the presentation, yes, from this nice, very simple notebook that, yeah, some count, sentence length, average word length. So you can just calculate this and try to write something like a short, long, so on, so forth. And maybe it will be helpful. I don't know. But there is some space for experiments.
Like always
Yeah.
in Kaggle competition.
Yeah. Faith, so you asked at some point about this prompt title, prompt questions. So now they're shown on the screen. Is it?
Yeah, I see it, Sasha. Thank you.
Okay. So here are the 4 summaries. One is Aristotle, and now another about Egyptian system, then the third wave, and then excerpt from the jungle. You see, well, I don't know.
If we put after state, it's not helpful.
Sorry, can you say it again?
If we put name of after of this text, it's can't help us.
Well, that's an idea. I don't know. Well, so this is a trained model. It has been trained on many texts, so maybe it knows something about the author and something, I don't know, the style of the author. So it might, in some sense, help, but I don't think there are big chances for that. But in theory, I don't know. If it would be ChatGPT, it might be quite helpful, but our DeBERTa is not that much powerful as ChatGPT.
If we have time, we can look through second notebook, or we haven't time.
Well, second notebook, it's like the first one, but maybe just more technical. It's just that we have added the cross-validation here and have added lots of kind of reporting the scores on each fold and some plots and so on, so forth. So the kind of main thing which I wanted to discuss is about how to make this training for 2 targets and also for cross-validation. But no, I don't think that we have lost much not discussing it. So, yeah, so just technical here, for example, this is the merge of the columns. Yeah, so, I mean, my idea was to kind of repeat the first notebook. Repetition is mother of learning. So repeat with small details. So this is the core part of the second notebook. It's more or less the same. So you can see the same preparation. So we start with the false. It's new for this notebook, but then we do these things. Prepare the data set. So that means the conversion. Yes, so we have this from pandas dataset. Then we have again this function to tokenize, which with the map and tokenize function, it converts this dataset into the tokenized form. Then we use this auto model for sequence classification. Yes, that is just the core model for this. Then we have this class trainer, which makes the training. The main command train.train. It takes lots of time, yes, especially on the CPU. Well, on GPU it can be just 7 minutes, but or 30 minutes, depends on the. But on CPU it can be 7 hours. Yeah, so it just was the idea to repeat with some small changes. Then we have the inference. So we have the validation set. Again, we construct the data set from pandas, then we tokenization, then switch into the inference mode, prepare the arguments, which are very technical, just says do train false, do predict true, batch size, and so on. Yeah. And here the difference is in the preparations. Yeah, so as I said, so the suggestion for the homework is the following. So if you want to predict two targets, not one, we should change the two things. One is what we already discussed. That in config, we should say two targets. Yes, it's very simple. But another thing we should change in this tokenizer. This we should put here the list, this line. So if you want to make, if you want to do the homework, pay attention on this line. So since we have not one target, but two, we should put them, all of them in this list. But all the other things are the same. Yeah. So here you can see the cross-validation scores, the cross-validation by each fault and so on. So, but that's more technical, more related to the competition itself.
If we have 3 line and average of 3 line, and then we have 5 line and average of this 5 line, can we make procedure of find value before averaging?
You mean to blend several models?
No, go to screen where you write pair that repeat 4,000 times or some, no, pair of targets and count of how often it together.
Okay, just a moment. Yeah, so this notebook actually can take care of many targets, not only two. So I should assign this list of the targets in appropriate way. So my data frame should have several columns which correspond to this list of the targets, and all of them should be numerical. Then we can predict several targets. Actually, it's one of the ideas how to kind of try to improve this competition, because we can ask the model to predict not only the original targets, but for example, their rotation and something like that. And maybe it will help. I don't think it will help much, but maybe small help for the model it can provide. I'm not sure.
It's a third notebook where you count how often one value of target and it's third notebook.
This one?
Oh, here. And can we if we have content, value of content, can we I think value of warning is aggregate in window of value of content, but and I want to calculate original value of warning, and I don't know how to make this.
So I don't think that we have some natural way to calculate the wording from the content. So actually for the training data, we have this way, but this way is not kind of good way. If we, for example, these plots. So here, first I ordered, I think, the content. Yes, so this blue line is the content, and samples are ordered one by one. And the orange line is this another target. I guess it's wording. And you see that if we smoothly change one of the targets, the other target can change quite a lot. That means that there seems
I think it cannot change at all. I see that if content has value of maybe 1, it's knows that it means that warning can take only one value. It's fixed.
Yes, you are right. Yes, there is this point. Yes, you are right. But there is a problem that if you have, for example, content has value 1, as you say, but then we change a little bit. Content is changing by 1. Don't.
Okay. Yes.
The other can change very big change. That means for the predictions you cannot say that.
And we can make one model that predict real wording, and then we can calculate calculate error of real wording like aggregation. We don't have target for warning, but we have aggregate target for warning, and we can calculate. But
I think we can discuss it maybe in separate. I'm afraid today is too late to discuss such things. But in general, yes, I see also that we have the correspondence, but then I think on this.
No, wait, if we have we have is it true that we have not real value of warning? Yes, we have only aggregate value of warning through window. Yes, and if we find real value of warning, then but then we cannot find aggregation for answer.
I think in this kind of so real value should be somehow like that on the latest. But here you see the same, that for one content you have many wordings. So there is no function, there is no kind of hope for some.
No, for one content we have only one warning.
It is kind of formally true, but informally it will not work. Because of this, you see that kind of, yes, that was something like they prepared the data. I don't know in what way that this happens, but when you small changes, everything breaks down. But you cannot predict that much precisely, so that you will be able to use this correspondence. So what you say for one target, we have for one wording, we have one content. Yes, it is very unstable. If you change a little bit, then it breaks down.
It's very stable, because if we find a real warning, it's stable, and we cannot find. If we have real warning, we cannot find aggregation. It's true, but if we have but real warning value is stable. Aggregation value is not stable. Okay, it's true.
No, I don't think so.
Aggregation value not stable because of little change in content can make a big change in warning. Okay, yes?
Yes.
But if we find real value of warning, it will be stable because its real value is not aggregation. It's not change. It change little if content change little. It's
no, I don't think that this is like this for the real values, because no, kind of it's like marks for the school children. For example, if you have 5 in physics, that doesn't mean you have 5 in mathematics. Or yes, it's something like that. So you have content very good, but your wording can be very bad, or both can be very good. So I don't think that there is natural way to find this correspondence.
I don't say about correspondence and say about that warning has its natural value, and competition gave us aggregation value. It's different targets.
What do you mean by aggregation value?
Warning is average of all warnings in window in one value of content. You gave one value of content, and then you average warning in this value, and it's our target.
But what do you mean by that? What do you mean average?
Average means 1 plus 2 divided by 2.
No,
it's average.
No, but
average.
Who is 1 and who is 2?
Student 1 have mark maybe 4 in content, and student 2 have mark maybe 3 in content.
No, but you don't.
Or maybe
just a moment. You cannot average the marks of the different student for the student, for this particular student.
warning is average.
No.
Content is real. Our target content is real target content. It's you have.
Why do you think that wording is average?
Because I order by content, and I see that wording is average in window in one content value. select all target and order by content, and you see that warning is
No, these are the plots, so it's ordered by one, and you see.
you can not make plot, but output like table.
No, okay, okay.
Only value of
Maybe we
content
can
target.
discuss it later. I propose to stop for the moment. Okay, so I think thank you very much for that you were here.
Thank you, Sash.
Thank you. Okay.
Thank you
so
very much. Bye bye.
Bye bye. Thank you very
Can
much.
you send links to your slides, please?
Yeah. Okay. I'll send you the slides. Yes. Okay.
Thanks.
How to stop the recording? Just a moment.